Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the class 10 exercise questions of chapter 12 electricity of science. So the question number 9 says a battery of 9 volt is connected in series with resistors of value having 0.2 ohms, 0.3 ohms, 0.4 ohms, 0.5 ohms and 12 ohms respectively. How much current would flow through the 12 ohm resistor? So in this question we need to find out the current. How much current should flow through the 12 ohm resistor? So if we have to draw the circuit diagram of this question, let us draw the circuit diagram first and then start our question. So for the circuit diagram, we have been given the volts equal to 9 volts. So let us draw the circuit diagram. Then it is connected to 5 resistors of having the values 0.3 ohm, 0.3, 0.2, 0.3, 0.4, 0.5 and 12 ohms. Okay, respectively. Okay, and they are connected in series. So let us connect them, all the resistors in series. Okay. Okay, so let us say this is 0.2 ohms, this is 0.3 ohms, then 0.4 ohms, 0.5 ohms and this is 12 ohms. So we need to find the current in the 12 ohm resistor. Okay, but now here one thing is to be noticed is that all the resistors are connected in series. So current is not divided in series. Whatever the current will flow through this resistor, that much amount only current will be flowing through this 12 ohm. The total current will be flowing through this circuit. So first we need to find out the total resistance. So in the series the resistances are get added up, okay, directly. So the resistance, equivalent resistance in the series circuit is given by R1 plus R2 plus R3 plus R4 and plus R5. Okay, they all are added up. So here we will be adding all the resistances 0.3 ohms plus 0.4 ohms plus 0.5 ohms plus 12 ohms, and it will give us a total of 13.4 ohms. Okay, when we will be adding all the resistors, then we will be getting the value of 13.4 ohms. So this will be our equivalent resistance value. Okay, equivalent resistance value. Now according to the Ohm's law, V is directly proportional to I, or we can say V is equals to IR. Okay. So according to the Ohm's law, the voltage is directly proportional to the current. And if we remove the proportionality sign, then we get V is equals to IR. R is the resistance value over here. So the I, current, will become V upon R. Okay. So we'll be putting the values of V and R. So the value of V is given to us as 9 and R we have already been calculated over here, 13.4. So when we will solve it, we will be getting a value of 0.671 amperes. Okay, so this is our answer. Okay, ampere is the unit of current. So in the series the current is not divided. Okay, so whatever the current, the total current will flow through this circuit and the total current will only flow through the 12 ohm resistor. So the current through the 12 ohm resistor would be 0.671 ampere. We can write it down at the bottom also. Current, therefore, current through 12 ohm resistor is 0.671 amperes. Okay. So basically we should know what is Ohm's law. Ohm's law is the law which states that at constant temperature and pressure the voltage is directly proportional to the current, or V is equals to IR. Okay. So now let us move on to the question number 10. Question number 10 says, how many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? Okay. So we have been given the current value, we have been given the voltage value, and it is asked that how many resistors of 176 ohm. We are having the resistor of 176 ohm, but they need to be connected in parallel. So we already know the parallel equivalent is given by 1 upon Rp is always given by 1 upon R1 plus 1 upon R2 plus 1 upon R3, and it goes on till n times. Okay, so this n we have to find out. Over here, this n value we need to find out from here. Okay, so let the total number of resistors be n. Let us assume, let the total resistors be n. Okay, we have assumed this in the beginning itself. Okay, so now the value of R1, R2, R3 is the same, because the 176 ohm resistor only is to be connected in parallel, and then we need to find out that how many such resistances should be connected so that we should get the 5 ampere on a 220 volts line. So first of all, let us find out Rp value. Okay, so as according to the Ohm's law, V is equals to IR. Okay, so R equivalent, this is the equivalent value. Okay, so R equivalent will be equal to V upon I. Okay, so V upon I will be equal to, V is given to us as 220 volts. Okay, V is given to us as 220 volts over here. So putting the value 220 over here and the current value 5 amperes over here. So on cancelling, we will be getting 44 ohm. We will be getting as 44 ohm. Now we will be putting this value over here, and we will be putting the value n times. So for calculating any value n times, n get multiplied in it. Let us take an example. If 5 is to be calculated 5 times, so we multiply it by 5 times. Okay, so in the same manner, 1 upon 44 will be equal to n into 1 upon 176. Okay, it will be equal to n into 176, because from here it will be, we will be getting 1 upon 44 to be equal to 1 upon 176 plus 1 upon 176 plus 1 upon 176 till n times we will be getting, because we have assumed it to be n times. Okay, so we will be multiplying it n times. Okay, we will be multiplying it with n times. Now in order to find out the value of n, 76 will be, it is in divided form over here. When it will go on the other side, it will get into multiplication over there. So 1 upon 44 into 176. So therefore n we will be equal to, let us cancel it. It will go 11 4 will go 11 times and 4 will go here 44 times. Again 11 ones are 11, 11 fours are 44. So ultimately n value comes out to be 4. Ultimately the n value comes out to be 4 as a answer. So the number of resistors required to be connected in parallel in order to carry the load of 5 amperes on a 220 volts is 4. Okay. So let us write it down. Number of resistors connected in parallel to carry 5 amperes on a 220 volt line is 4. Okay. So in this manner, we need to apply the Ohm's law accordingly and we need to solve the questions. So in the next videos, in the next lectures, we'll be solving more of the numericals of this chapter. Okay, so thank you. So please subscribe my channel, please share my videos, and if you have any doubt, you can ask me in the comment section. Thank you.